Hello, and welcome to section 11.3, the product and quotient rules. Two rules. Once you know the rule, just apply it over and over and over again, and don't forget, parentheses are your friends. So the product rule says, if f of x and g of x are differentiable functions of x, then so is their product, f of x times g of x. And the derivative of the product is the derivative of the first times the second plus the first times the derivative of the second. Now, this is all good and stuff, but you might also think of it like this. If y equals u times v times, then dy dx is, oh, now I'm going to mix my symbology here. Let me erase that. Let me use the correct symbols. Keep it consistent. Y prime is first times derivative of the second times plus second derivative of the first. If you have two things you're multiplying, you leave one alone, take the derivative of the other. And we add along the way. Leave one alone, take the derivative of the other. And this extends. If you have u times v times w, you leave one alone. If you have three, you take one derivative, leave the other two alone. Move on to the next derivative, leave the other two alone. And finally, the third derivative, leaving the first two alone, and so on. It just expands from here. Always multiply, and you always add from the product. So let's find the derivative. Y equals 3x squared times 2x plus 1. So I'm going to break it down. This y function, right? It's the function 3x squared. So I'm going to call that f of x is 3x squared. Multiplied by the thing in parentheses, I'm going to call that g of x equals 2x plus 1. And we now have y written as f times g. But you see this f, that's not hard. Little side work here, 3x squared. We know how to find the derivative. 3 times 2 is 6. Remember the variable, subtract 1 from the exponent. So the derivative of 3x squared is 6x. If we take gx equals 2x plus 1, remember this is a linear function. What is the slope of a linear function? It is the slope, the coefficient of x. The slope is the derivative of 2. So now I can put these together. I'm going to use the, let me see. I'm following these instructions here. So I have the derivative of the first, leave the second one alone, add to that the first times the derivative of the second. So as long as I'm multiplying, let's change colors. Multiplying kind of acrosswise and adding the results. That's all I need to do. That's why I write these on the side. Now we can distribute. 6x times 2x is 12x squared. 6x times 1 is 6x. 3x squared times 2 is 6x squared. When I add the x squareds, I get 18x squared plus 6. Side note, if you distribute first, take the derivative, you're right here. So your question to yourself is, do I want to do algebra and then find a derivative? Or do I want to take the derivative using the product rule and then a little bit of algebra from there? You're never going to escape the algebra. You're never going to escape the derivative. It just depends which one do you want to do first. All right, second example, y equals in parentheses x to the 0.7 minus 4x minus 5 times x to the negative 1 plus x to the negative 2. First function, I'm going to call it f, x to the 0.7 minus 4x minus 5. Second function that makes up this product, I'm going to call it g of x equals x to the negative 1 plus x to the negative 2. I take my derivatives. Remember, x to the 0.7, I bring that 0.7 up front. Now I take 0.7 minus 1. 0.7, think of it as 70 cents minus $1. I'm in the whole 30 cents. Derivative of negative 4x is negative 4. The derivative of negative 5, that's a constant. All constants have zero derivative. My second function, x to the negative 1 plus x to the negative 2. My derivative, I bring down the negative 1, subtract 1 from the exponent. Don't forget your x. And since I'm bringing down the negative 2, I just dropped out on my plus sign. I used negative 2 as the operator coefficient. And I subtracted 1 from my power of x. So now when I put it together, I have f prime times g plus f times g prime. and I don't want to simplify it, and I don't have to, and you don't have to either. You do have to remember your parentheses though. Parentheses all around the f prime. Parentheses around the entire g. Parentheses around the entire f. Parentheses around the entire g prime, so that if you were to multiply it, you would be able to do it correctly, and anyone following your instructions could as well. You're like creating a recipe for others to use. Okay, so f of x, number 3, f of x is the square root of x times the product, x to the 5th plus 3x squared minus x to the negative 3. All right, so I have first and second, and that's how I always think about it. In my head, I say first derivative of the second plus the second derivative of the first. It's not that way in the definition. I try to keep consistent in here. But remember, when you're multiplying two things, it doesn't matter which order you multiply them, as long as we're not dealing with matrices. When you're adding two things, so it doesn't matter which order you put these in and within the individuals. So, don't worry so much about order. Just make sure one's a derivative and one's the original as you do these in pairs. Here we go. F of x is the square root of x, which we know is x to the 1/2. Calculus is easier on rational exponents than it is with radicals, so I'll use that 1/2 and I'll find the derivative. I'll bring 1/2 coefficient down, leave the x, don't forget about that. 1/2 minus 1 leaves a negative 1/2 in the exponent. My second piece, x to the 5th plus 3x squared minus x cubed, minus x to the negative 3. I called that g of x, so I can have a notation for my derivative, g prime of x. Bring down the 5, leave the x, subtract 1 from the exponent, 5 minus 1 is 4, plus sign. I'm going to leave the coefficient and multiply by 2, right, when I bring it down, so 3 times 2 is 6. Leave the x. 2 minus 1 is 1. Mathematicians are too lazy to write an exponent of 1. This minus x to the negative 3, when I take the derivative, I'll have a minus, and that coefficient has a negative 3, so minus a negative 3 becomes positive 3. Don't forget the x. Subtract 1, negative 3 minus 1 is negative 4. When I put this all together, notice how I leave the derivative in in rational exponent notation, and then my g of x, but I leave my original function in the original notation. I've even mixed notations here, and no regrets whatsoever. So we have f prime times g plus f times g prime every single time. That's how we're going to put it together. So really, finding the derivative of a product is find two derivatives individually and then put them together according to the formula. So I take my first, x squared minus 3x plus the absolute value of x, and I take its derivative, 2x minus 3 plus absolute value of x over itself. Remember, that was a definition given in section 11.1. The second piece, 1 over x cubed minus 7 over x squared plus 2. My first step, I'll rewrite with negative exponents. So I want the x to the third from the denominator to come up here across the fraction bar. So I change the sign to x to the negative 3. Minus sign. 7's all good, so it'll stay there. X to the negative 2, it's from the denominator. I want to bring it up to the numerator, so I switch the sign of the exponent. My goodness, talking is hard. I'm like 5-6 videos deep today. Okay, we're good. And then plus 3 doesn't need rewritten. But now that we have, instead of looking at little mini fractions, we have negative exponents. These are easy to find derivatives of. That's negative 3. Leave the x. Subtract 1 from the exponent to get a negative 4 exponent. Minus 7 times minus 2 gives us positive 14. Don't forget the x. Negative 2 minus 1 is a negative 3. And our constant has derivative 0 that we never seem to write, but it's kind of always there. Put it together. We will have f prime times g plus f, original f, times g prime. And that's it. That's all we have to do in order to find the derivative of a product, is we kind of do some mixing and matching and look at the individual pieces of that product. So now let's talk about the quotient rule. If f of x and g of x are differentiable functions of x, then so is their quotient, as long as g of x is not the zero polynomial. The derivative of the quotient is g of x times f prime of x minus f of x times g prime of x, all divided by g of x squared. Horrible, horrible math definition. Something I want to point out. Because of the subtraction, order matters. Okay, now we have to make sure we get it in the right order. So I wrote it out in words. Here's the best words, and this is what a student gave me a long time ago. And it is low, d high, so the function in the low spot, the denominator, derivative of high, derivative of the numerator, low d high minus high, the function on top, the function in the numerator, d low, derivative of the low, the function in the low place in the bottom in the denominator, over low squared. So this is what I say all the time. Low d high minus high d low over low squared. If I'm doing notes, I'm writing notes for you guys, if for some reason somebody say, quick, do this calculus problem or else whatever, this is what I would say to myself. So let's find some derivatives using this. I'm going to separate it according to this low d high and high d low. Instead of using f and g, as was a little confusing in the product rule above, now we're going to take low, 2x plus 4, our denominator, and high to be our numerator of 3x minus 9. All right, always low, denominator, high, numerator. From there, derivative of low, derivative of 2x plus 4 is 2. Derivative of 3x minus 9 is 3. Remember, a derivative is just a slope. These are both linear, so the derivatives are straightforward. Now, putting these together, always start with low. Always start with low. Low, d high minus high, d low, all over low squared. Low d high minus high d low, all over low squared. Notice I didn't simplify this. This says find the derivative. It doesn't say find the derivative and simplify. So I'm going to leave it here. You could absolutely multiply it out. Notice the extensive use of parentheses. Every little piece gets parentheses. Every time I substitute one of these, I'm putting it in parentheses to make sure I multiply correctly, and to make sure I distribute my negative correctly, and to make sure I square the whole thing and not just a couple little values. All right, so here's y equals 3x squared minus 9x plus 11 all over 4x minus 1. Nice rational function where low, the denominator, is 4x minus 1, and high, or the numerator, is 3x squared minus 9x plus 11. Once I've identified that it's a rational expression or a quotient, I identify my low and high. Once I identify my low and high, I find the derivatives of each of them, which you're totally good on by now. I know it's only 2 sections later, but you got this. All right, find the derivative, pause if you need to. It's a quotient. I have low and high. I can find my derivatives. Now I use my words. I have low, 4x minus 1. D high, 6x minus 9. And I've every time, low, 4x minus 1 in parentheses. D high, 6x minus 9 in parentheses, minus high times d low, each in their own parentheses, over low squared. All right, over low squared. In general, my rule is, if you're going to use it, simplify it. If all you're trying to do is find it, it doesn't matter how nasty it looks. It'd be nice if we always simplified. But another quit while you're ahead. If this is correct, and we're learning calculus, let's not lose points on algebra, right? Okay, now let's take a look at this. It's so tempting right here. See that 4x minus 1 and that 4x minus 1? You really want to cancel. But there are 3 parts to this. There's 1, 2, 3 parts. The 4x minus 1 from the first part does not cancel the 4x minus 1 in the denominator because it's not also in the third, in this part over here. So it must be a factor of all places to cancel from any place. Okay, it must be a factor of all before you cancel any. 4x minus 1 does not appear over here, so I cannot cancel that out. End of story. All right, so a simplification note. Number 3, my low is 2x cubed minus 14x squared plus x. That's a nice little polynomial. Derivative will be 6x squared. That's a 2. That's an x squared, if you can't tell, because I can't. Minus 14x squared. Minus 14x squared has derivative minus 28x to the first power. And the derivative of x is just 1, because if my function was y equals x, my slope would be 1. High is square root of x plus 7. The square root of x, if I were to rewrite that, is x to the 1/2. X to the 1/2 plus 7 has derivative 1/2 x to the negative 1/2. I told you you're going to hear that one so many times. You're going to be so sick of it in chapter 11. But we're still going to have it in chapter 12. And the derivative of 7 is 0, so there's nothing else. I put it together. A quotient has a specific rule where it says low, d high, minus high, d low, all over low squared. All right. That's it. You can do the individual pieces. You can absolutely put them together. Calculus. Calculus is easier than algebra. I swear to you. Last example, f of x is x to the negative 6 plus 7x cubed minus 1 all over the absolute value of x. I identify my low as the absolute value of x, and d low, therefore, is absolute value of x over itself, over x. High in the numerator is x to the negative 6 plus 7x cubed minus 1. The derivative being bring down the negative 6. Don't forget the x. Subtract 1 from the exponent. Minus 6 minus 7. Minus 6 minus 1 is negative 7. Moving on to the next piece. 7 times 3 is 21. Leave the x. 3 minus 1 leaves us with an exponent of 2. And the derivative of the constant term is 0, so we don't write it. Putting this together, we have low, d high, minus high, d low, all over low squared. Product and quotient rules. Nothing new, really, other than once you find the individual pieces and you find their derivatives, how do you put them together? That is product and quotient rule. Thanks for listening.